Okay, in today's lesson, we're going to write chemical formulas. So first of all, we need to understand what is known as valency. So by now, you understand the basics of the periodic table, that it has groups, group 1 to group O. So we have group 1, 2, 3, 4, 5, 6, 7, and group O there. So now, each of these elements in these given groups um, has a number of electrons equal to the group number. So those in group 1 have 1 electron in the outermost shell. Those in group 2 have 2. Those in group 3 have 3. Those in group 4, 4. Those in group 5, 5. Those in group 6, 6. Those in group 7, 7. And those in group O have 8. So when we are talking about the valency, it's important for you to understand that the valency for group 1 is 1, group 2, 2, group 3, 3, group 4, 4. And then for group 5, the story changes because for an element to be stable, it needs to have 8 electrons in its outermost shell. So as a result, we are going to take note of the number it is lacking. So if an element is in group 5, it means that it has 5 electrons in the outermost shell. So for it to be stable, it needs to gain 3 more. So that is the valency. And then if we go to group 6 there, it has 6 electrons in the outermost shell, so it's lacking 2. And then for group 7 has 7 electrons in the outermost shell, so it is lacking 1. And then actually for group O, it doesn't need anything, and that's why it has a valency of 0. So we should also remember that uh, the, the metals, that's group 1, group 2, and part of group 3, these are positively charged. And then those that non-metals, that's group 5, they're nitrogen, oxygen, fluorine, and the others that are on the other side, they'll have a negative charge on them. So now, when you're writing chemical formulas, you should always remember that the first letter is always supposed to be a capital letter and then followed by a small letter. And then when these combine, you are going to just take them the way they are presented on the periodic table. So if you are a fan of writing, let's say, um, B with a small letter, you need to know that the first letter always is supposed to be a capital letter. And whenever you're writing any chemical formula, the first letter is supposed to be a capital letter followed by a small letter. That's for each individual element. So in this case, you need to know that others have got 2 letters, others have got 1 letter. For example, if you look at the chemical symbol for lithium, lithium, we have capital letter L and small letter I. And then if we look at other symbols, for example, carbon there, it has only capital C. So we should always abreast ourselves with the letter notation there. So now, first of all, if, for example, we want to write the chemical formula for carbon dioxide, we should be able to understand that, first of all, carbon, the letter that we represent carbon with is capital C. So write capital C there. And then let's say it combines with oxygen. Oxygen, also we have capital O there. Now, earlier on, I said that we should take note of the valencies. So I've displayed the valencies there. So we're saying that if carbon has a valency of 4, we're going to take then when we go to oxygen, we know that oxygen has a valency of 2. We'll write it on top there as a superscript. Now, we should always remember that these uh, elements combine as single atoms. So the subscript we're going to write there will be a small one there and another one there. So when these combine, we are supposed to interchange the valencies. You cross multiply the valency with the number of atoms for the other element. So this one will go with that one, and then this one will go with that one there. So this one goes down there, and then the other two on the oxygen goes down there. So we are going to multiply them. So if we multiply 4 by 1, it eventually will give us 4, and then 2 by 1, it will give us 2. So we're going to have something written as that. I'm sure you understand that this 4 we have displayed there is coming from the carbon, and the 2 we have displayed there is coming from the oxygen. So once these interchange, it means that now we can express this to its simplest form. So if we said C2O4, definitely 2 can go into 2 and 2 can go into 4. Then we have C. So now, apart from that, you need to know that once we have that chemical formula written, always remember, whenever you are given elements, they should always follow the same rule. Do not forget the valences there. That is why it's important you know the valences of the elements there. I must make mention that for the transition metals, they will have a valency which can vary from between 2 and 3, because they're in between the two groups there. So now, once we have that, I'm sure if we got sodium, for example, in group 1, the valency is 1. We are saying that it's 1 atom, plus chlorine. Chlorine there, the valence is 1 atom. When these interchange, we simply have that sodium chloride, like that. What about if we decided to get, let's say, calcium in group 2? So if we have calcium, we're saying it has a valency of 2, 1 atom. With chlorine that side, chlorine has a valency of 1, it's 1 atom. When these interchange, we have that as the formula for calcium chloride. So it's always important for you to remember that, first of all, the elements in group O are not going to form any compounds there, because already they are stable. They don't react with anything. So you can have a wide range of these others reacting with one another there, but you should always take note that that is what we're going to have there. So now, once that has been done, what about if I decided to get lithium, for example? If I get and then I also get bromine, you're going to find that this one has valency of 1 atom, valency of 1 atom. When they interchange, we're going to get lithium bromide, like that. So it's important for you to remember, if I decided to get the famous hydrogen, for example. Hydrogen has a valency of 1 there, and then it's a single atom. If I go to nitrogen, nitrogen has a valency of what? 3, and it's a single atom. So if these interchange, then things change. 3 there, and then an N there. But for convenience's sake, we know that this is written as NH3, which is the symbol for ammonia there. So now, once we have that written, I'm sure by now you can see the importance of you knowing the valency. The valency is basically the combining power of elements. It signifies the number of electrons an element is going to either gain or lose for each to combine and form compounds.